Hello, for data communications and network one class today, Ajahn will continue with the network topology and we'll go to the star topology. Star topology is very important network topology. Okay, so we are still in the topic of the network topology. Okay, the star topology use a central connecting point, okay, which is maybe a hub or a switch, and I will tell you about a hub or a switch in a little bit. Okay, all devices are individually connected to this hub or switch. Okay, so look at this picture. This picture is simple to understand. Okay, you have a hub. Okay, and every node is connected directly to the hub. Okay, as I told you before that I try to avoid the problem with the with the right, okay, like copyright. So I try to use like picture from like old textbook or that is reference, and also picture from like website like wiki or something that is allowed to use, or maybe just one picture from like a website, something like that. So I try to generate like AI generated image, okay, which is nice, this one, but sometimes they are like too nice, so they have like more information, okay, than needed, okay. This is already simple star topology, okay, but I want to tell you that the device only communicated with the hub or the switch, okay, they do not communicate with each other, so this is correct, but this one you have to be careful, okay. So this line are correct, but they are not connected to each other, okay, directly. Okay, anyway, I will try to make like maybe more more AI generated image also for other topics, okay, if I can find that it fit perfectly. Anyway, so this is the topology, and this is how they are connected. They do not communicate directly with each other, okay. Look at the advantages and disadvantages of the star topology. There are many advantages because it's very common topology nowadays. Okay, very reliable. If a cable fails, only one node is down, but you can see that they are connected to the hub or the switch like this. So if this one is down, only this one cannot use. Okay, the other are still okay. There is no collision because everyone send only to the hub, okay, or to the switch, and then the switch will send out, okay, to other users, okay, to other device. So they do not have like the multi-access problem, which is the main problem for the local area network. Um, that we have to avoid more than one person sending at a time, okay. Easy to add or remove devices, okay. You can see you just add one port, okay. You use each device only need one input output port to plug into the like the switch, okay, to connect to the central point, okay. As I say, I will talk to you about the hub and the switch in a little bit. Now for disadvantage, okay, use more cable than a bus. This is for wire network, okay. Actually, the star topology can use for wire network and also the wireless network. Is also common topology for wireless. If we use for wireless, it will be just like sending. They do not have the actual cable, physical cable. It's just signal sending, okay. So this is like wireless network. The another disadvantage is that if the hub or the switch fails, okay, the whole network will be down, okay, because they cannot connect with each other, but directly they have to send through the central point, okay. And there's also added cost of the hub or the switch compared to the bus, because the the bus, this is bus, but does not need the central point, component, and the hub of the switch will be like the switch will be like a good switch will be like more expensive, right? Okay. Now compare the hub and the switch. The network hub is a simple device. This is older than a switch. So in modern network, okay, most of the central point here will be switch, not the hub, okay? But you can still maybe find the hub in some like basic function or older network, okay? Anyway, the hub is broadcasting. So if you have suppose this is a hub, okay, and you want to send from A to B, C, D, E, F. You want to send from A to E, okay? You send, okay, the signal in bit, okay? Let's suppose it's send 1011, something like this, okay, to the hub. The hub will send the bit sequence, okay, to everyone. So it's broadcasting. So even though so the E is the intended destination, right? So E will read it, but the other should ignore. They should ignore, okay, because it's not intended for other user, okay. They have to they receive the signal, but they have to ignore the signal, okay. So this is like not efficient, okay. So only the intended, okay, destination should read it. It's not efficient, and it's have problem with like the security, okay, because everyone got the like the signal or the bit sequence of everyone else, okay, which you have to ignore. But if you are a bad guy, okay, or if a person is a bad guy, get into the network, then they can read the signal, they can read the message, okay. So you have to do something like maybe encryption, okay, to make sure that the other cannot read it. So it's added problem to solve, okay. Anyway, when hub receive the data, it sends them, okay, to all connected devices. That's why it says broadcasting. But broadcasting is the basic concept for LAN, local area network, okay. In the past, they are using like all broadcasting, okay. The hub is operating in the layer 1 of physical layer of OSI model, okay, and the send data in bits is half duplex, okay. So it's lower data rate than the full duplex, okay. Half duplex means that when you send, then the other has to listen, okay. You have to wait, okay. Half duplex means only one side can send and the other side has to listen, okay. Okay, then talk about the network switch, okay. Network switch is smarter than hub, okay, and replace hub in modern network. So this is important device right now, okay. It have like routing table in the switch, okay. So this is like switch, okay. Suppose A want to send to E, for example. A send packet to E. It will look at the routing table, okay. Have the MAC address, and it will say like which line to go out, okay. You have seen the routing table before, okay. Use the MAC, which is medium access control addresses, okay, to send to only the intended destination. So only E will receive it, the other will not see it, okay. B, C, D, F will not see the packet, only E will see. So it's more make more sense, right? That you send to the only the intended destination, okay. but you have to calculate more because it's have to have routing table. The hub is like easier uh, to build, okay, because the hub is like you just broadcast, you don't care, okay. The receiver will just be the one to read if this is my information or not, or should I ignore it, okay. But in the switch case, okay, the switch will be the one who make decision using the routing table. We don't need like this cross routing algorithm or anything because it's only one hop, okay. So switch operate on the layer 2 or data layer of the OSI model, okay. Send data in packet. This one can be half duplex, full duplex, okay. So faster if you use full duplex is faster data rate. Okay, now let's look at the switch, like Ethernet switch, okay, which is the one that we use in the local area network, okay, for the LAN, which is LAN, okay, for the star topology, okay. So for the LAN standard for star topology, okay, we have switch Ethernet, and this is the device like this, okay. I think you may have seen it before. We have the standard, for example, IEEE 802.3 BP 2016, and it's still used right now. It's still to have amendment up to now, okay, 2024. This one we use twisted pair. This means twisted pair, okay, and 1000 means 1000 megabit per sec. It's the data rate, or 1 gigabit per sec. Base mean baseband. Okay, this one use switch Ethernet, and also if we use fiber like 4 gigabit Ethernet, 4 terabit Ethernet, they all use switch Ethernet. Okay, in the old standard, okay, old standard Ethernet use bus topology, okay, bus topology. This is in the old standard. As in the early Ethernet, okay, early Ethernet, like standard is like 10 base 5, 10 base 2, 10 means 10 megabit per sec, base means baseband, okay, 5 means 500 meters, 2 means 200 meters, coaxial cable. Okay, so both use coaxial cable with different size diameter. Anyway, so right now in the new standard we use twisted pair and fiber optics, okay. But the old standard, which is what this was very popular like in the 90s, okay. But it's still in the standard right now, okay. The standard of IEEE Ethernet 802.3 have defined from 1 megabit per sec, okay, up to for the standard of IEEE, okay. I was just checking a few days ago. So this is in the standard of IEEE Ethernet. So it's still they still use it, okay. Now for the bus topology, we will have the multi-access problem, okay. Multi-access problem, which means that we cannot send more than one user send at a time, okay. They will collide. In this case, we will use a protocol that's called CSMA CD, carrier sense multiple access with collision detection. This is for the bus topology, okay. Ethernet with bus topology, we use CSMA CD. This is an old protocol, okay. It's not used in switch Ethernet anymore. If you look at my like old lecture notes or old video, okay, we will explain about CSMA CD a lot. but in the new version of the clip videos, I think I might explain just overview on the seismicity and not that much detail, okay, as this is not used much anymore. Okay, anyway, we'll talk about that more in the Ethernet topic. And the star topology, okay, is a common topology for wireless network, okay. And for example, home wireless network, okay, the phone, the tablet, the printer, they are connected to the wireless access point. The wireless access point is the central point that everyone connected to, and the wireless access point can also connect to the internet, okay. So you may have seen this, okay, in your home, okay. So that's it, okay, for star topology. I'm trying to update the information, okay. You have to keep up to date also, okay, if you are in this field, okay, on what is going on in new technology, okay. So thank you very much.